This is a demonstration of how we increase the success rate of MSIX conversions by using our own PowerShell module to automate the injection of package support framework fixups. Consider the following couple of directories. The first one at the conversions is where we'll use the MSIX packager to automate the conversion, and we'll copy our resultant packages into that directory. The ones that we launch and they don't work, we'll move them to the failed conversions directory with a view to injecting the package support framework into those packages and trying to fix them that way. The example today I wanted to show you is an application that I wrote myself called Rubbish App, and it's called Rubbish App because it doesn't actually work when converted into MSIX format, and I want to show you why. If we launch the package, all it does is it tries to write to a log file inside the VFS, and you'll see that when it attempts to do that, we get an ugly error message saying that the file doesn't exist because it's not been able to write to that location. And if we look inside Process Monitor, we can see where it's trying to write the log file to, and we can see that it's also getting an access denied. So we can try and fix this using the package support framework. So let's remove that package. And we actually have a module that we use to automate the injection of the package support framework. So you can see here, when we're configuring it, we provide the input path to our broken MSIX, the output path to our fixed resultant MSIX, the staging location. Now this is where it extracts our broken MSIX to inject the package support framework. We provide our certificate for signing our resultant MSIX, the architecture of our package. This will also determine the architecture of the PSF runtimes that get injected. The PSF type, so we can either specify MS for Microsoft or TM for Tim Mangan's version. And the download location to Tim Mangan's package support framework. Once we're happy with that, we can install the prerequisites. So that is both package support frameworks, the Microsoft version and Tim's version. We'll stage our broken package so that we can inject the framework. We'll start to build our config.json now. So we'll add an application and we'll add a file redirection fixup. You can see what we're doing here. The base of this is actually the Rubbish App directory. So this is where we're trying to create our log file, and we can see the fixup pattern is indeed the log extension. We'll generate our config.json here, and finally we'll compile and we'll sign our new, hopefully fixed MSIX package. So let's just run that now. So at the end of it, you can see the config.json that it's created. And we can open that at the end of each conversion by just specifying open config.json or open config.json. And if we look into the package at what it's done, we can see that it's created our fixed MSIX, and we can see our staging location where it's generated our config.json and it's injected our 64-bit PSF runtimes. So let's try that package. We'll go into the fixed directory and we'll try and add the package. We'll launch it. You can see it's trying to write the log file and it's trying to open it. But now we get a different error message. It's no longer the ugly error. We can see that it's trying to open Notepad, and Notepad's trying to open the log file, but it doesn't look like it knows where the log file is. So let's just click cancel there. If we look in Process Monitor, that will confirm that it's trying to open the log file inside the VFS. So it looks as though the log file has been created in the redirected location, but Notepad is still trying to open it in its default location inside the VFS. So what this implies is that the PSF runtimes have not injected into that Notepad process. If we look into debug view, we can see that it does in fact inject into rubbishapp.exe, but we can't see anything beyond that in relation to Notepad. So make a mental note of that. What we can do then is we can remove that package and we can try and inject Tim Mangan's version of the package support framework, and we can literally change the PSF type, run it again. that will compile our new package, and we can test that straight away. And when we launch it, you can see that it's trying to write our log file, but we get the previous ugly error message again. Luckily, if we consult Tim's documentation, we can see that there are indeed dependencies for the file redirection fixup. And luckily, I've got a local copy of those. So all I need to do is, before we compile the new package, I need to copy those into the VFS. If I run that now, and we look inside our stage location, we can see now that we've copied those runtimes inside the VFS prior to compiling it. And if we try running the resultant package now, you will see that it works as intended. Interestingly as well, if we look in debug view, we can actually see where it invokes notepad.exe to open our log file. So Tim's version of the package support framework injects the PSF runtimes into this process. So this is like a process which has been spawned from our rubbish app further above. So that's an improvement to Microsoft's framework. So well done, Tim, and thank you for that. I'll close that application now, and I will remove it, because I wanted to quickly show you a more complex example. Again, these are just examples. The fixups don't actually do anything, but I just want to show you what it's capable of. So here we get all of the applications from the manifest, and we iterate through them all to add, for example, a working directory fixup, if you will. Further down, we show examples of the different fixups we can add: trace fixups, environment variable fixup, dynamic library fixups. We also show how we can get all of the files inside an MSIX package by their file extension. We can iterate through those, and if we wanted to, for example, we add a file redirection fixup here, and we pass in the base path of that file and fixup patterns. Again, just an example of what's possible. It's not actually doing anything interesting there. Here we add a start and an end script. We add a capability to the manifest. We add a dependency to the manifest. And once again, we generate our config.json. We copy our runtimes. And then finally, further down, we compile our MSIX package. So if I run that complex example, all I want to do is show you the output of the config.json, so you can see the start script, the end script that it's added, all of our fixups. And if I close that, and we'll take a quick peek inside the Apex manifest as well, and you can see that it's added a dependency down here, and the other change is the allow elevation capability that we specified. Now, interestingly, what we can do in terms of, let's say we've got multiple packages that failed, and we've lumped them all into a failed conversions directory, like this example here, we can actually provide default fixups, generic fixups for packages. And what we can then do, what it allows us to do, is it allows us to iterate through our directory of failed conversions, filtering by the MSIX file type, and then we can follow the process that we've demonstrated previously, and we can add working directory fixups, and we can add generic fixups further down. So for example, if I look into the directories here, these are our broken MSIX packages. They're just sitting there alone. But if I iterate through all of those automatically, and I wait for those to convert and inject generic fixups, at the end of it as well, in this example, I delete the staging folder, because if we're running this en masse and there's hundreds of applications that we're injecting the fixup into, we don't really want to be using all that disk space for staging folders. So if we look in one of these now, you'll see that it's just got a fixed directory and hopefully the fixed MSIX package. So if I show you an example of that now, If I go up a few levels, I go inside our failed conversions, I find our first app, I go into our fixed location, and I add this package and launch this package. So again, this is a generic fix-up that we've applied, some generic rules. You'll see that it works.